An object moving at a constant linear speed will undergo uniform circular motion if it experiences a constant acceleration that is perpendicular to its direction of motion. This acceleration is called centripetal acceleration and is directed towards the center of the circular path. Acceleration is defined as the change in velocity divided by the change in time. In uniform circular motion, the magnitude of the velocity remains constant while the angle changes with time. So the centripetal acceleration is written in terms of the rate of change of the angle with respect to time. But since the rate of change of the angle is called the angular speed, then we can define the centripetal acceleration in terms of the angular speed as centripetal acceleration being equal to the linear velocity multiplied by the angular speed. Since angular speed is equal to the velocity divided by the radius, then centripetal acceleration can also be written as velocity multiplied by velocity divided by the radius, or velocity squared divided by the radius. Finally, the centripetal acceleration can also be written as the radius multiplied by the square of the angular speed. I'll leave it for you to derive that equation, but it's very straightforward. Let's go back to the rotating Earth example from the last video, where we determined that the angular speed of the Earth's rotation was 7.3 by 10 to the negative 5 radians per second, and the linear velocity at the equator due to the Earth's rotation was 465 meters per second. Using one of the formulas previously derived for centripetal acceleration, calculate the centripetal acceleration that is experienced by the person standing at the equator. In summary, the centripetal acceleration, which causes an object moving at constant speed to move in uniform circular motion, can be expressed in terms of the linear velocity as a velocity squared divided by the radius of the circular orbit. Or it can be expressed in terms of the angular speed as a product of the radius and the square of the angular speed. The unit for centripetal acceleration is the same as linear acceleration, that is, meters per second squared.